All right. Good morning, everyone. Today we will be solving the Of a River 1 puzzle on CodinGame.com. And if you watched yesterday, I was solving or attempting to solve another puzzle, which I ended up finding out that it was a hard puzzle. It was in the hard category. And I didn't have time to finish solving it, unfortunately, uh, on air, but I did finish solving it after lunch using a clever little algorithm. This morning I should be able to finish this one. It's in the easy category. So, but let's see what happens before we, yeah. Anyways, okay, so here's the problem statement. The goal. A digital river is a sequence of numbers where every number is followed by the same number plus the sum of its digits. In such a sequence, 1, 2, 3 is followed by 1, 2, 9. Since 1 plus 2 plus 3 equals 6. Okay. Oh yeah, so 123 plus 6 is 129. Get it. Which again is followed by 141 because 1 plus 2 plus 9 is 12. 129 plus 12 is 141. Get it. We call a digital river River K if it starts with the value K. For example, River 7 is the sequence beginning with 7, 14, 19, blah, blah, blah. And River 471 is the sequence beginning with 471. Yep, okay. Given two meeting digital rivers, oh no, hold on. Oh yeah, digital rivers can meet. This happens when two digital rivers share the same values. River 32 meets River 47 at 47, while River 471 meets River 480 at 519. Given two meeting digital rivers, print out the meeting point. I think that'll be easy enough, but we'll see. Okay, let's just set things up here. Whoops. Okay. And we're going to set up Code and Game so I can use my external editor. Let's see. The river. That's the file we'll be watching. Upload from local file to Code and Game. Yes. Good. We're in business. Can get rid of that. We can get rid of that. Tell TypeScript about the readline function. Then readline returns a string. Okay. So what's our input though here? First line is the first river, the second line is the second river. Right, and that's the starting number of that river. So input 32 and 47. Okay. So right off the bat, the only difficulty I see, well, difficulty here. Like generating the river seems pretty easy to me. I don't think it's going to be complicated to do that. The question is like, how do we set it up so that we just don't generate the river to infinity, right? We can stop once we've found the place where both rivers cross or meet. But let's start by generating a river, finding out a way to generate the river. So if we're starting off with, let's make it a function since we're going to be using it twice. Function generate river. And whoops. is going to take our starting number of type number, and it will return a, shall we make it an array? Yeah, I guess we can. Let's do that. Makes sense. Okay, so given a starting number, oh no, it's true. I should probably make this a string. And okay, let's keep it like that for now. I should make this a string because I need to check every digit in our number, which is a string, but is a number represented as a string. Okay. So the first thing we need to do is to look at every character of our string and split that. So how about we do this? Array dot from starting number, and that will give us an array of each digit. Then we can take that and reduce the, like this, that. Okay, so we're basically just taking our, hold on, what is it saying that P is a string? Yeah, but ideally we'd want that to be a number. Start with 0, no, that's good. We'll just take P. Right. How about that? First, let's convert everything to number. Oh, I learned that little trick yesterday. Really like that. If you're wondering what's going on there, we're just basically passing the number constructor, which you can pass a string to the number constructor and it'll return a number. So we're basically mapping our entire array of strings with the number constructor, which returns a array of numbers, and then we're reducing that in order to get a total. So we're just doing P plus C, and that should work. So that should give us a sum. And then all we need to do to get the next number is take our starting number or just parse int, and then what are we doing? Oh yeah, we're just adding the sum. And that gives us the next number in the chain. Yay! So how about that? Generate next number. Return. So let's test this just for kicks. Make sure we get this right. So if I go generate next number, and I pass in, for instance, 123, it should be taking a string. Yes. So like that. Don't need this. Don't need that. Let's run this in here. We don't care. We just want to see our output. 129. Right? If we're getting 123, we should be getting 129. 129 should give us 141. So let's Another test. 141. Okay, so our function works. Generate next number. Now what we need to do is go through and generate the river. Generate river is going to take, this time we're going to go starting number, starting number of type string. That's kind of funny, but that's what it is. And this time we will return a number array, I think. And now all we basically need to do is recursively call, yeah, we can make this a recursive function, right? We can make this a recursive function. Ooh, we can make this a recursive function that, Okay, let's just see what this would look like for the one river. But I've got an idea that maybe we can use later for checking on the two river thing. Generate river, starting number. Okay. So if we wanted to do this recursively, we would do, well, we'd basically do generate next number using starting number. So far, so good. And then we just call generate river, generate river. No, we need to push that to something, right? So we need to be, this will be our river, is going to be of type, well, let's initialize it right here, like that. But also let's give it a type, number array. Okay. So we've got this. Now we need to push that to our river. River, not push, generate next number. But no, we'll actually need that too. So let's do that. So it's the next number equals generate next number. You know what? Why am I making this a string number? I'm passing in a string. Maybe I should just return it as a string, because I do need it to be a number to do math on it, though. This, then I'm parsing it to a number, return C, so sum is a number. If, yeah. Seems a little silly, especially since JavaScript will usually, but this is, yeah, this is fine. Let's do it that way. So we're pushing our next number to our array. River string. Pushing that to our array, and we're calling generate river with our next number and our river array. Okay, good. Now this will run to infinity, so I need a way to stop it. Now that's the interesting thing. I need a way to stop it and return. So if this should be return, I think. Well, we'll get to that later. So let's say if starting number. Oh, let's see. We probably have as part of our constraints. There we go. The first river will always be. Both of them will always be smaller than this number here. So let's start with that as a condition to stop. So if we get to bigger than that, then we can stop. Return river. Okay. And it's going to ask us to do this. That's right. It's a string. Yes, I know. So parse int will make you happy. There you go. Okay. Now, do I want to see what that does? Make the whole thing crash? Why not? Because we'll end up with a crazy long generate river, crazy long array. Let's see how it handles this. Let's start it at, I don't know, 157. Oh, it's got to be a string. 157. Hate dealing in numbers with strings, but can't be helped. Avoided in this case. Okay, maximum call stack size exceeded. Yeah, that was to be expected. That was to be expected, so we're going to have to deal with that. Let's look at our test cases. Maybe even bigger. Okay. Oh, wow. Okay. Okay. So doing this recursively might not be an option. Might not be an option. Now, I think tail recursion or whatever that's called is supposed to prevent that. But, and I'm pretty sure it's been implemented in JavaScript. Let's see. Tail recursion, I think it's called. Tail recursion is a recursive function where the function calls itself at the end, tail. The function in which no computation is done after the return of recursive call. Yeah, so tail recursion optimization. What is tail call optimization? Yeah, that's like that. Very simply, what is tail call optimization? Tail call optimization is where you're able to avoid allocating a new stack frame for a function because the calling function will simply return the value that it gets from the called function. Yeah, that's what we're talking about. The most common is tail recursion in unreadable. This looks like one of those crazy all parentheses languages, Lisp or whatever. No, what we want to know is tail call optimization in JavaScript. Is it here? Does it exist? As a merchant, Safari is the only browser that supports tail call optimization. but this is running on Node, so let's see. Code and Games JavaScript engine is Node, I believe. Tail call optimization, Node. What happened to TCO? TCO was supposed to be included. It looks like it was implemented, however, not as a standard feature, and then later removed again. Anyone know what happened to it? Blah, blah, blah. Alright, so what I understand is that it's not implemented. So, yeah, we're going to have to do something else than recursive functions here. Otherwise, we'll blow the stack. Boom! Okay. So what do we do? That is the question. Well, of course, loops. That's pretty much our only option in these situations. So, forget about you. Forget about that. And then we don't need this. Boom. String. Yeah, that's what we're expecting to return. We need to initialize this here. River equal of type string array. No, string array. String array. Okay. Okay. Now we need our loop. Right here is going to be a for loop. I equals our. Should we? What's the 0 to. Oh, and that's the first river. There's no telling, it might go even higher than that. The river might go higher than that. 1, 5, blah, blah, blah. Yeah. Okay, so this seems to be the biggest number here. So we're safe to use that 2 million or however many zeros are in there. And we start, quite logically, we start with the thing is, it's gonna jump though. It's not sequential. Well, it is, but maybe a while loop? While, yep. Okay, while makes sense because here's what we're gonna do. While next number is smaller than let's just copy it because I don't know how many zeros are in there. What are we talking about here? Let's see. So this would be 1 million and this is 20 million. Okay. Next number is smaller than that. You keep going. Next, put that here. We'll make that next number here, which ends up being a string. Then we go next number, generate that. Oh, of course, it needs to be an actual number to do that. Check. Next number is a string. Parse in converts a string to an integer. What is your problem? Is used before being assigned yes, of course. So at first, next number is simply our starting number. Okay, we've got a loop instead of our so elegant recursive function, which should do we needed to do. We need to return river here. So let's just recap here. We are starting with a number, which is a string. We're declaring, initializing our river array. We are assigning the starting number to our next number variable. We're looping until we reach 20 million. And then we're generating our next number with the starting number. River.push. We're pushing that next number to our array, and then we keep going as long as we hit that. Okay. Let's see what happens. I think this is correctly implemented. It's going to run forever, of course. Process has timed out, so that's another problem. Okay. Well, that is interesting. Let's make this 1 less 0. See how much we can get away with. All right, let's take another one out of there. See if this times out again. Looks like it did. Wow. Well. So we're down to 20,000. That seems odd to me because it is not a very heavy operation we're doing here. It doesn't seem to me like it is, right? How is it timing out and just... Unless there's something wrong with my algorithm, which could very well be... No, there's something wrong. Generating 2,000... Not even 2,000... Am I maybe not? Okay. While parse int is smaller than 2,000. Well, next number is smaller than 2,000. Okay, let's get ridiculous here. 200. If that doesn't work, there's definitely something wrong. Yeah, there's no way it should take that long. We're starting off with 157. Huh. Okay, let's what are we gonna do here to solve this? To debug this, right? I can't really debug. It's running on the... Well, I could write a test for it. I could run it just here in my file. Yep. Could certainly do that. Let's see if we can reason this out though. While next number is smaller than 200, do these things. Well, how about this? Just 157. So 1 plus 5 plus 7 plus 157. That would be 170, right? So let's do this. Technically, there's only 2 of them that needs to be generated. How would that time out? Yeah. Yeah, so for some reason my loop, I think, is just running forever, no matter what I put in there. Why would it do that though? Why would it? Okay, let's do this. This is a string, so every time we're parsing it, we're checking that it's smaller than a certain number. How would that end up running forever? The thing now is that since we have an infinite loop, if I try to, yeah, I'm gonna have to. What happens if I try running this here? Let's do that. Let's open another terminal here. Let's use our trusty TS node. And what is this called? Main. Am I in the right directory? No. Need to go into source. Source main.ts. Let's see what happens. TS node is not recognized. Oh, don't I have TS node here? I do. Oh, I gotta do npm TS node. npm TS node. I guess it's not installed globally or something. Main.ts. Now what? Oh yeah, okay. So that's not it either. Oh, I'm not in the right directory. That's why. Yeah. Okay. We'll get there. No, still. How about this then? You will do my bidding. Read line is not defined. Oh yeah, that's a problem. So let's just forget about this whole part. I don't need you anyways to make this test. Just want to run this. Oh boy. Yeah. You can clearly see that this loop is just going on and on and on and on and on and on, and eventually we'll get some kind of error message saying, dude, it looks like you're running some sort of infinite loop. Wow, okay, yeah, let's just kill this. Now, how do we debug this thing? I'm always, let's see. Will it know if I just hit F5? Will it just do the debug configuration properly? I'm interested in this here. So let's try this. Because it's running TS node, so yeah, I cannot launch a program. I think I have a default unless I try to debug this thing here. Yeah, let's try that instead. Maybe that'll work. And TypeScript out of the box. That'd be cool. And we're interested in this here. Ah, Looks like it does. Okay, so next number is 157. That's right, because that's what we're passing in. Next number is a string. Correct. So we're good. Let's keep going with that until we get to the next one. Now we're at 170 and we've put that into our array. Good. I like what I'm seeing. And then for some reason we're going again and passing 170. Okay. What have I done wrong? Ah, do you see it? I see it. We're using our starting number over and over and over again instead of using a next number to generate the next number. So we're basically ending up with 170, 170, 170 forever. Debugging to the rescue. Thank you. Just go back to our terminals. Lower that a little bit. Simple fix, switching that to next number. And now we can go back to our 2 billion, 20 million, 120, 1, 2, 3, 1, 2, 3. Let's see. Will it time out? No, it won't. And 652,626 more items. Cool. So, okay. So I guess we could just quite simply do, we're gonna need this again, need that. So we could just generate river 1, generate river 2, and find where they cross. Right? Can they meet in more than one place? Print out the meeting point. It seems to be saying there's only one meeting point. All right, so let's do river 1. Const river 1 equals generate river with R1. It doesn't like R1. Why doesn't it like R1? Type number. What? Oh. No. I'll actually take your string. Just give me the string. Got everything set up for the string, so let's go with that. Const river equals generate river R2. Then we take what can we do to compare? Oh, there's a much better way to do this. I'm doing too much work here. What we need to do is actually find meeting point. Find meeting point. And this will be river 1. And this will be river 2. String. Q. Don't even need to store this. That's what I'm thinking. Actually, let's just delete all of that. So what we're going to do is generate each river in sync, really. until we find a matching thing. So okay, all right. So let's do that. So let's start with if river 1, and we're going to mutate these. Yep. It'll be easier that way, I think. If river 1 is bigger than river 2, then go ahead and give me the next river 2. All right, the way we're going to do this is we're going to advance river 2 until it matches river 1, then advance river 1 by 1, then so if river 1 is bigger than river 2, then river 2 is equal to generate. This is no longer good. Generate next number, river 2. Okay. So of course we're going to need to loop this while river 1 is not equal to river 2. Because when they are, we can return river 1. It'll be, yeah, we're just interested in the string. So, okay. While river 1 is not equal to river 2, do this. River 1 is bigger than river 2, then river 2 becomes this. And then go again. But if it is, and let's use an else here. Else, it means that either river, oh wait, how am I not getting a syntax error here? It's interesting. Python. Okay. So while river 1 is not equal to river 2, if river 1 is bigger than river 2, then generate the next number for river 2. If river 1 is not bigger than river 2, and we know that it's also not equal to, because otherwise it wouldn't be looping, it means that it's smaller. And if it is smaller, then we need to generate our new river 1. Generate next number, river 1. How's that? Okay, I think we've got it. This looks good to me. So let's find meeting point between R1 and R2, and do this. Oh yeah, see how fast that was too? Oh, and why would that be? If R1 is smaller than R2, yeah, if R1 is smaller than R2, do this. What seems to be the problem? If R1 is smaller than R2, so in that test case, we're starting with 57 and 78. Starting with 57 and 78, so what happens? debug. Now that 57. No, let's not change that. Instead, let's just do this. And this will be our testing thing. 57, 72. They need to be strings. Is that right? 57 and 72? 78. Okay. 78. And let's see what happens when we debug this. And we're interested in seeing, I guess, the entire thing. Cannot launch program because oh yeah, forgot about that. I gotta go into the sorry guys. This is where I need to debug. Okay, so we're starting off with 57 and 72. 78, sorry. 78. We're getting to our while loop. Let's see what happens when we get in there. If river 1 is bigger than river 2, which it isn't, then you do this. Generate next number, river 1. Yes, thank you for generating the next number. That gives us 59, 69, yeah. Then it's still not equal, yeah. It's still smaller, yeah. We jump to this one. Don't need to get the details. 84, okay. Now it's going to be bigger. It's going to be bigger. So yeah, this catches it right here. We're running this. 78 should become 93. We're back to this. If river, okay, that's right, because it's smaller. So we're generating the number. It becomes 96. Let's skip ahead. It's 105. Generate the number. 111. Whoa. Wait a minute. This is where we have a problem. If river 1 is 96 and river 2 is 111, how are we? What? Oh, I'm comparing strings. Am I not? And it's screwing up the whole thing. I need to get numbers in there and I'll fix everything, I think. Am I not? Yeah, I am. That's why it's looking for. Okay. So this is fine though. This I can compare strings here. But this, I need them to be numbers. See, this is why mixing strings and numbers and parse int 2, that should fix everything, I think. Let's take a look. Try this. Try that. What? Okay, you're getting on my nerves now. R1 is bigger than R2. Expected 620 and we found 111. What are the numbers we're using here? 5 and 7. 7 and 5. River one is 7, the other one's 5. Oh, yeah. Oh, okay. Way to go, Phil. Still have that test case here. Let's try that again. This will work. Yes. Yes. Play all test cases. And we are done. Okay. Let's clean that up a little bit. Get this out of the way. Let's bring this here. Like that. Anything else we need in here? No. I don't think so. I don't think so. That wasn't too bad, was it? Do I need to refactor some of that stuff? I mean, it's pretty easy to understand what's going on here. This is our generate next number function, starting number. And they're strings. I really hate that they're numbers represented as strings, but that's the output we're expected to give, and that's the input we're getting. So that's just what we're going to do. All right, let's roll with that. Submit. There we go. Submit. It'll be interesting to see what the other users' solutions have been. This was fun. Yeah, this was fun. So let's give it a 5-star. Loved it. And let's see. Next step. Browse the best solution for this puzzle. Let's do that. This guy has 16 score. 16. He's got 3 down votes though. Probably because this thing is unreadable. No. He's using a class. Wow, that's pretty cool. Yeah, it's doing the same thing that I'm doing here. R1, using ternary operator. R1 value is smaller than R2 value, then R1. Print R1 value. Yeah, okay, I get it. The value equals this value, while value this value plus equals divided by 10. Wow, okay, he's using like, this is binary stuff, isn't it? Don't know what the heck's going on there. I'm not Let's look at a normal person's solution. There's that sum again. Why are they checking if it's evenly divisible by 10? Oh no, they're getting the remainder. They're taking the remainder of whatever that divided by 10 plus the sum. So that's recursive. They're using a recursive function here. Divided by 10 or 0. Wow, okay. This guy's doing the same thing here, more or less. I guess there's something here, there's something mathy here that I didn't get. That wasn't the only one. This guy's doing something similar to what I'm doing. I really wish those guys would, when they have clever solutions like that, that they would like comment it or something, just for benefit of everyone else, right? So, what is happening here? Oh, right. Okay, instead of they're actually using the number, if the number is smaller than 10, return the number. Right. Because there's no digit digits to add. If it isn't though, divide it by 10, get the remainder, and then recursively, oh, of course. That's pretty clever. That is pretty clever. I don't know that it is more performant than doing what, well, probably, but okay, cool. This will be something I'll try to remember next time. So, by using the remainder, I don't know if you understand what's going on here. So what we needed to do was, right, let's say we had 123. We needed to get the total of 1 plus 2 plus 3. So what I was doing is just splitting that. I would get it as a string, split the characters, and just add it. Add all of them. But one way to do it with just a number instead of a string is to go 123, and that's what these guys were doing. A remainder operator divided by 10. So in that case, we would get, what would we get? We would get, let's see, divided by 10, is my calculator gonna, 12.3, right, but I'm interested in the remainder as a, complete number. Is there a way to do this on a calculator? Probably. I don't feel like looking it up though. But whatever. You get the idea. Is that basically you're doing the remainder of 10 here. You'll end up with let's see, 10, 20. How would that work? I haven't done that in a long time. But anyways, they're doing this recursively, so basically they're ending up with like they're doing it for the 100th basically, for each 10th position. Yeah, so it comes down to doing the same thing as adding each number. It's pretty smart, really. I should look that up. I can't remember how to do the remainder thing. By hand, I mean. But anyways, that's enough for this exercise, for this puzzle. And we've got a full hour left, so we can probably move on to another code and game puzzle. That's what we're going to do. Next step. There we go. So let's go to, or we could, I've never done this before. I think there's like some live competitions you can try. This seems like a big contest. Clash of Code. Join a 5-minute coding battle. Oh, I'm gonna get my ass kicked if I try this. They're probably like speed. Yeah, there's speed based, I'm guessing. How about we look at another classic puzzle. Well, we could do the river 2, right? How about we do that? What is that all about? A digital river is a sequence of numbers. Yep, we're aware of that. Just been through this. Digital rivers can meet, given a number, decide whether it can be a meeting point or of 2 or more digital rivers. For example, it is easy to check that only river 20 contains the number 20 in its sequence as a starting point. Whoa. What? So given a number, decide whether it can be a meeting point of 2 or more digital rivers. For example, okay, well, so obviously if we're given the number 20, the only possibilities for rivers to meet at 20, it can be a meeting point, yeah, are rivers that start below that number. Wonder if there's a clever mathematical way of doing this, but let's try it. See if we can brute force our way into an answer for this. We've got a lot of the work done already. So first I will commit my solution. So add solution to the river 1 puzzle. Push that up to GitHub. And we will, don't need you anymore. Get into that, and we'll make a new on the river, new project, the river 2. I want this to be more like a library. I don't need a Git repo. Generate the files. Good stuff. The river. Okay. So we're probably not going to need this other terminal now. The river 2. Okay. Let's also commit that. Add the river 2 puzzle. Get our starting code from this here, like that, and npm run dev to start building and watching this file, and then in here set up external code. Upload from local file to coding game, and we're in business. Okay, so we're getting an integer, and we're expecting to return either a yes or no string in capitals, capital letters, uppercase, and the integer will never be more than 100,000. Okay. So, don't need this, but I do need TypeScript to know about the readline function. It returns a string. Don't need this. So how do we go about this? Well, we can generate Okay. Actually, we can reuse some of that stuff, right? see. In the river one, we had find meeting point. So yeah, let's export that. You can just reuse that here. So find meeting point. Is that not what it's called? Find meeting point. Oh, but wait. Let's just grab all of that. Because I think we're going to need to modify it. Well, not this, but... Okay. So what's one simple way to do this would be to take our R1 and go, oh, they don't even, okay, so we just need to say if more than one, hold on, is it? Given a number, decide whether it can be a meeting point of 2 or more digital rivers. Oh. So that's quite simple, really. So let's go for, I think it's simple anyways. I always say that, then I end up finding. Hey, colorful catter. How you doing? And as long as it's smaller or equal to our R1. And we increment this. And find meeting point. Find meeting point of river 1, which will be R1, but it needs to be toString. And I dot toString. Doing well. First time looking for coding streams on Twitch. Not an awful lot of them, sadly. What you coding? JS, I'm guessing. Yeah. Yeah, you're right. There's not that many of them. I mean, compared to like gaming streams. But there's quite a bit of you. You'll find some. I am coding in TypeScript, transpiled to JavaScript. I'm doing a puzzle on codingame.com at the moment. The concept is not that complicated. We're basically, the instructions are here. Well, you know what? I'll let you, because I've already gone through them. Here's the link. Go check it out if you want to catch up to what's going on a little bit. What do you code in? All right, so that's our meeting point. JS, HTML, CSS mainly, and getting into SQL, PHP now. Cool. All right. Good Good stuff. You're a junior in school. Okay. Right on. Where are you from? From Holland. Okay. Yeah. Um, so what does the school system look like over there? If you say you don't understand the English school system. Um, I'm from Quebec, Canada, and we also have a bit of a different school system. So we've got like kindergarten, which is around age 5. Then you do primary school for 6 years. So years 1 to 6. Then you end up in junior high for years 7 and 8. And then high school is 11, I know, 9, 10, 11. We don't have a year 12, which I think most English school systems have, and they go to university straight from there. We have like kind of a something before, after high school and before university, which we call college, which gets really confusing because for people in the United States anyways, college is the same thing as university. But anyways. Okay, if meeting point is equal to R1, meeting point will be a string. R1 needs to be a string as well, toString. Then just break out of that loop. And console.log, a resounding yes. If we do the loop and we don't get anything, then we just console log no. How's that? Want to choose, what's this? Okay, yeah. Okay, let's see what we get by running this. I have a feeling there's something wrong there, but I'm just curious to see the output. Oh, that's not a good sign. Timed out. 0, I is smaller or equal to R1. I++. Okay. So yeah, you're in higher education. You finished your what we would call high school here. You're in post-secondary school. Okay, so I've got a loop that just keeps running here or something. Runs too long. Starting with 0, as long as I is smaller or equal to R1, I keep going. How do I get to more than another? Let's debug. Let's debug. See what happens. See what's going on in here. F5 for the win. you. So are we running here? What's going on? Confused. I am confused. This is the one we're trying to debug. Isn't it? Yeah. If I put that here, 5. Oh, I think I know what's going on. Nope. This all seems... Workspace, derivative, just derivative. Yeah, that's the one I'm trying to debug. What are you doing to me? Yeah, of course you won't be able to do that. That's probably where the problem is. Try this now. Nope. Why can't I debug this? All exceptions. Let's see what am I getting an exception? What is going on? Okay. Exception has occurred. R1 is not defined. Oh, yes. That would be a problem. Yes. So let's stop that for now. It's got to feed it something. So R1 is just going to be let's say 20, because that's what we're doing, I think, at first in terms of test case. Yep, test 20. Okay. Let's debug again. So we are in debug mode. I think it's just looping right now continuously. So let's stop that. Let's put a breakpoint here again. Let's try it again. Okay, now we're in business. So what are we looking at here? Meeting point is undefined at this point, so let's keep going. What is going on? Oh, it's getting stuck somewhere else. Right. Yes, because my meeting point, okay, so this is the problem. My meeting point function here that I'm using looks for the meeting point, But if there is no meeting point, well then it just keeps running, trying to find a meeting point. Okay, so I need to modify this. Let's go back to the drawing board. I'm just gonna use some of that logic here. Let's see. Yeah, let's throw another if statement in here, where if river 1 is bigger than river 2. Yeah, we already have that actually. Right. River 2. Hey man, thanks for following. So, okay, river 1 will be, I can probably keep what I had then. In that case, we'll just adapt it. Right, we are giving it R1, and this is the incrementing one. So if river 1 is bigger than river 2, we do that. If else, then we're just gonna throw. How's that? Throw a new error saying no meeting point. No meeting point. It's kind of a hack, but it saves me from rewriting the whole thing. So then I can just do meeting point. This should all work still. We're just gonna do a try here. Let's just shove the whole thing in here. Like that, and then a catch. Console log no. Interesting. What am I doing wrong? Don't have the right brackets here. Wait, the starting numbers of the two rivers are not determined, right? You are writing a program that can see if two given numbers meet. Yeah, the two starting numbers aren't given, except one is kind of is. What I'm doing is we're given a number, right? And we're being asked to check if there is any two rivers that have that as a meeting point. And they don't want to know how many rivers have that as a meeting point or what rivers have that as a meeting point, just whether or not two or more rivers have that as a meeting point. So essentially all you need to do, let's say our number is 20, as is the case now, you need to check that all rivers below that number, right? You need to check them to see if they meet at that number, is what I'm thinking. And so if you compare if you compare each, so from 0 to 19 to the 20, to see if they have that 20 as a meeting point, then you're good, right? That's kind of what I'm doing. It's kind of a hack because I did you know what? Maybe we should just start from scratch because I'm using some of the functions I was using in the River 1 puzzle. That's right, yeah. The river higher than 20 can never meet at 20. It's pretty obvious, right? So, but really, this is kind of a back-assward way of doing this because I don't really need to compare two rivers. I just need to see if the one river actually gets to 20, right? So, and I'm just trying to force this function into the, so that, you know what, let's just scrap this and scrap that. And we'll just write this clean. This is still good though. So all we really need to do is make a river. So let's see if we generate our next number starting with I. Okay. I being a number, I need it to be a string because that's how I wrote it. Okay. So we're going to need some kind of a loop. So while let's call that let candidate equals I. No, equals, yeah, because that's where it's going to start. While while candidate is smaller than R1, generate the next number. And this will be our candidate. Candidate, so the type string. We need it to be a number for this, right? So let's give it a number. Okay. So what are we doing? We are looping and generating the next number until we reach R20, R1, because there's no point in going later over that. If we do reach it though, well, we need to return yes, right? That's gonna be our cue that, and actually, now that I think about it, this needs to be smaller and not equal. But if at some point I need to check candidate is equal to R1, then we can simply console.log. I need to break, yeah, I need to break out of break out of our loop, but we'd just be breaking out of the while loop. Okay, so instead let's do I can probably have let answer equals no for now. And then we'll make answer equals yes. Then we break. Then here we always do a check to see if answer equals to yes. Oops. Then we break from this one. Oh, I'm not sure. Is breaking from an inner loop, will that break just the inner loop or both loops? Or I have a feeling it's just the inner loop. So we're about to find out though. And then all we need to do once we're done with that is console log the answer. I think that works. Let's give it a try. It's taking a long time, which leads me to believe that I did something wrong. Let's go see what it is. Wait. Really, it shouldn't though. It's kind of weird. So let's debug. Because we're only trying it with the number 20. I mean, that's really shouldn't be a problem for the computer. So let's, well, first of all, let's see if, what are we interested in? We're interested in checking, let's see here, yep. Exception has occurred, read line, oh yeah, let's forget about that. So, one is 20. And let's try it again. Okay. Candidate is 0 because that's what we're starting with. We're starting with 0 here. So that's fine. It is smaller than R1, R1 being 20. Therefore, we are, oh, I see where our problem is, I think. Shouldn't this be inside the while loop? Yeah. Yeah, it should. Right. There we go. Will that have fixed our problem? We'll find out. Well, at least it doesn't run forever, but we're not getting the right answer. We're saying yes when indeed we were expecting no. How come? That's the question. Why? Break, while candidate R1, if candidate equals R1. Answer yes. Our candidate should never go up to R1. How can it, oh, not checking for equality here. R1 if, oh no, that's, candidate parse if candidate is equal to R1. So it should be smaller or equal here, because otherwise you'll never get to that. Let's try it. Let's try it. Uh-oh. We made it boo-boo. Time for some more debugging. Reference there. Oh. Yes. $20. Okay. Run that again. Candidate is 0. If candidate is equal to... Oh, you can't start with 0. That's the right. Because if you start with 0, there's no river. You can't start with 0, and you can't, well, you can start with 1, right? Because 1 would be 1 plus 1, and it'd be 2, and 2 plus 2 would be 4. But 0, you'd just be stuck at 0. And I think that's our problem. Okay. Here. It's got to start at 1. See what this does. No, we still have a problem. So let's debug this some more. Okay, this is good. Next, if candidate, which is 2, right, it's not, then we go again. Candidate will be, no. Oh, I see what I'm doing. I see what I'm doing here. This should be candidate. Candidate. Okay. Let's try this. Yes. No. Why? Lucky 13. I wonder why 13 doesn't work. Probably because of this. Okay. Let's give that a try. Yep. Yes. Play all test cases. Ooh. Timed out. So what is our problem here? 4AAA. So we're timing out when we're getting to 42,000. 9,000 didn't give us the problem. 42,000 times out. And now that means that we can't start with 0. But, yeah, of course, it would be more logical to start closer to the number. So, let's go with R1. I is equal to R1 minus 1. And instead we're going to go, we're going to decrement, and we're going to keep doing that until we reach 1. See what happens. Okay, we're good. Oh, 13 didn't work. This one worked, but 13 didn't work. That's interesting. Haha. Okay, well, it is much more performant, but some test cases are not working. So 13 is not working. Why is that? Debuggage. Debuggage. 13. Let's see what happens. Okay. That's interesting. Let's try that again. What? What's going on? It's like the debugger doesn't work. That's very strange. That is very strange. If I remove this breakpoint, see what happens. Nothing at all. What if I put the breakpoint somewhere else? Okay. For some reason it didn't like my breakpoint placement. That's weird. But now that's kind of useless. Let's see if I can break here. Okay. Let's continue. Yeah, it won't catch that breakpoint. That is some very odd stuff. Let's put it here, see. What? Well, that's annoying. What if I try this then? What does a breakpoint do? Never heard of it. Well, a breakpoint is used when you're debugging. So I don't know if you've seen that yet in your courses, but debugging is basically when you're running your program, you have a debugger. For instance, you might have seen that in Chrome itself, the browser, and Visual Studio has a debugger as well. And a breakpoint is that like red thing here that I'm putting. What it's basically saying is stop the program execution when you reach that point. And you're able to, okay, so this one worked, right? So I'll show you. So it's starting the debugger, it's taking a while. Now let's see, it stopped here. It executed everything here, it read everything, got to this here, and then it stopped. It paused. And then you get to inspect. You get to see the value of all your variables, of everything that's in the program's memory at that moment. It's very useful to understand what's going on with the program, and you know, where the bugs are. That's right, you can determine where the bug is. But for some reason, I'm trying to put my breakpoint here or here, and it just runs past it. It runs past it. It doesn't stop. It is pretty amazing. Yeah, it's very useful. It's very useful. So why? What if I just do step into? Okay, this could work. Let's try that. IS12. It goes straight to console log. Okay, could it be that, what did I do wrong? Oh, man, sometimes I -1. That is not what we want. Not minus, but it's smaller. So as long as I is bigger than or equal to 1. Sometimes. Yes, there you go. It's all test cases. So I was like, I don't know if you caught that, but I was setting breakpoints here inside that for loop, and the program would just run past them. And I was like, what's going on? Why isn't it catching any of those breakpoints? Well, that's because it was just the condition here would make it that it wouldn't loop at all, because I had made an error. Okay. So we're still timing out. And we're actually getting, what are we here? Are we timing out at that 40,000? We're timing out at that 40,000, so we didn't fix anything by doing this. I thought it would have helped. I thought it would have helped. So how can we make this more performant? That's the question. And we've got about 12 minutes to figure it out, because I gotta go at 11. 11 my time, whatever time it is over there for you, colorful catter. $16.49, okay. All right, so how do we make this more performant? Is there a better way to check if we are getting to, there must be some sort of mathematical way of doing this that I'm not really figuring out. And that I'm gonna feel really silly when I do find out what it is. So if we take our, for instance, 42,406. That's the number we get, and we want to know if there is another river. It is easy to check that only river 20 contains the number 20 in its sequence as a starting point. Right. How do we figure if this is in I really don't know. I am stumped. If there is a mathematical way to do it, I don't know it. And I'm not going to figure it out in 9 minutes, that's for sure. So in those 9 minutes remaining, let's see if, keeping with the same idea here, we can optimize maybe a little bit our algorithm. See if we can get enough juice out of it to not time out. How could we avoid checking every single possibility? How could we avoid doing that? Because, right, you can see how that would be a problem starting at 40,000. Is there a way to skip certain candidates and not bother with them? Again, it would, I think it has something to do with math. I could arbitrarily just go, let's try just even numbers, or yeah, there's probably a way to determine what numbers definitely not apply. Yeah, maybe there's probably some kind of math formula that would make it possible to see either what numbers can, definitely don't apply, or even maybe just get the answer. Yeah, I really can't figure it out. No. I'm gonna have to research this maybe. Because this works, this definitely works. It's just that it's computationally, it's too heavy. It is too heavy. I could, let's see, could I use some sort of other algorithm? Some kind of greedy algorithm. Yeah, maybe. But I don't think that's the right way to go for this puzzle. Because I'm basically brute forcing my way to the answer here, right? I'm trying out every single possible river until I get the right answer. There might be a way using some kind of random start instead of starting at one end and making our way to the other end, waiting to find the answer. There might be some way to start at random, boom, in the middle somewhere, and from there look at the adjacent possibilities and see, oh, well, we're further off, if we go that way, we're closer if we go that way, and I'm gonna have to think about that. Going to have to think about that. In the end, would we save time? Would it be longer? I'm gonna have to do some trial and error stuff. All right, well, I think I'm going to call it quits for today. Probably finish this in the afternoon and work on something new tomorrow morning. Or maybe not. Maybe I'll just come back to this tomorrow morning for my next live stream. We'll see. So thanks for watching, Colorful Catter. We'll see you around. Have a good evening for you, right? Yeah, 1649, so take care.